Glycerin at 68 degrees Fahrenheit is pumped through a 1-inch diameter pipe at a flow rate of 20 CFM, which is cubic feet per minute. Determine the type of flow. Once again, we are going to solve Reynolds number. So Reynolds number based on diameter is rho v d over mu. We need to go look up what the properties of glycerin at 68 degrees Fahrenheit are. And that's a density of 2.44 slugs per cubic foot. And then our viscosity is 3.13 times 10 to the negative 2 pound-force second per foot squared. And so we have all the other properties from the problem, so we can just start. Reynolds number based on diameter is density 2.44 slugs per cubic foot. Velocity. Velocity is 20 cubic feet per minute, but then it's not. Why am I saying it's not? We take a look at that. And this is another mistake that will happen quite a bit. Cubic feet per minute is not a velocity. That is a volumetric flow rate. We need to calculate that out. We do know that flow rate is V times A. So to find velocity, we take the flow rate, divide it by the area. So our flow rate is 20 cubic feet a minute. So we're going to divide that by the area. Now we want this to work out to be feet per second is our typical unit. So we have a 1-inch diameter pipe, so pi over 4 times 1 inch. Problem is we need that in feet, so we've got 1 foot is 12 inches. We square that. Now we have to get rid of that minute up in the top, so I know that 1 minute is 60 seconds. So now as I look at all these units, when I cancel out, inches squared will cancel out, minutes will cancel out, I'm going to be left with 1 foot per second. And so that's 61.1 feet per second. It's very important to do that. And this is also why units are really important, because if you did put the cubic feet per minute in here and you'd find that the units wouldn't cancel out, that should clue you in that something is incorrect. So 61.1 feet per second. And then our diameter. So that's our 1-inch diameter. And then 1 foot is 12 inches. We go to the bottom here, and what do we have is 3.13 times 10 to the negative 2 pound-force second per foot squared. Okay, now we go and we look, how do the units work out? Slugs, pounds force, there's a relationship, F equals MA. So let's go here and just remind ourselves, so 1 unit of force is 1 unit of mass times 1 unit of acceleration. So a pound force is a slug times a foot per second squared. So let's take a look at things. Those guys cancel out. So a slug, foot per second squared, right there is a pound force. So my pound force cancels. This drops this to a foot squared, squareds cancel out. All the units go away. Once again, now I am happy because I have a dimensionless parameter, which is what I should have. Now if I bash that into my calculator, I'm going to get a Reynolds number of 400. 400 is definitely below 2300, and so that tells me that I have a laminar flow.